Inversion of control is a fundamental pattern that allows to create a loosely coupled systems. In traditional flow, when component A has a dependency to component B, it is responsible to instantiate the dependent component and make calls to it. However, that creates tight coupling between those two components. In the inverted flow, an infrastructure is responsible to create components and then it assigns references. Then, when components make calls, they usually call against an interface than the actual implementation. That approach allows to completely decouple implementations and enable independent life cycles of the components. Most often, implementations of inversion of control are done as dependency injection. That approach was popularized by Spring Container in Java or Unity Container in .NET. Those technologies assign external references using reflection and pass them either through properties or through parameters in the constructors. However, not all programming languages support reflection. In Pip.Services Toolkit, our main goal was to create implementation that is portable across a variety of languages, including the compiled ones. And reflection mechanisms are not always available there. So for that reason, we choose a different approach described by the Locator pattern. In that pattern, a special component called Service Locator stores dependencies, and components are responsible to retrieve their dependencies before making calls. That pattern doesn't require reflection, and it can be implemented in any programming language. In the toolkit, instead of Service Locator component, we use a simple references objects that represents a map where keys are locators and values are component references. The references are populated by a container when it instantiates components. Then it passes references to the components that implement iReferenceable interface to setReferences method. Their components are responsible to retrieve their dependencies using known locators. On the slide, you can see the references interface. It works like a regular map with some minor modifications. It can store references using put method and then remove them using remove method. Then it allows to retrieve either all references or references by specific locator. Since under the same locator we may have multiple references, the methods allow to retrieve either all of them or only the first one. The difference between optional and required is that required returns an exception when reference isn't found, and optional return an empty result. On the example, you can see how references can be populated in the code. Objects of any types can be used as locators. For instance, that could be strings or numbers, but it's important that the locators should be known to the container and to the components that will retrieve references. In a way, it's a contract between those two to pass the correct references. And as I mentioned before, any object type can be a locator. But in Pip.Services, we often use a special type called Descriptor. It has 5 fields that can be used to find references using different matching combinations. The first field is called Group, and it defines the logical groups of components. Typically, it can be a microservice or a component library. The second field is a Type. It defines a logical type of component or its interface. The third field is called Kind. It represents a physical or implementation type. For instance, if component logical type is persistence, then kind can be either in-memory persistence, file persistence, or MongoDB persistence. The fourth field is a unique component name, and the field is component version. The component version defines specific interface version. In matching scenarios, some fields can be skipped or replaced by a star symbol. In that case, the field won't be included in the matching. That allows us to create various combinations to find different groups of dependencies. For instance, if we only mention a MyService as a logical group, we can retrieve all components that belongs to a MyService microservice. If I have MyService as a group, persistence as a logical type, and version of 1.0, then we can retrieve all persistence components from MyService microservice that compatible with version 1.0. If I need a specific implementation of a client, let's say a REST client, we need to include rest as a third field as a kind. If interested to find loggers, any type of loggers, we'll just use logger as a logical type and 1.0 as a version and skip all other fields. And when we need exactly a specific components, then we can use unique component name and skip all other fields. For instance, we may have a component that needs dependency to a logger. Then that component should implement a referenceable interface, and in the setReferences method, we shall retrieve a dependency to a logger. In that example, you can see that we use a descriptor that matches any logger that implements version 1.0 iLogger interface. But there is one small issue. If there are multiple loggers, then this code will retrieve a reference only to the first one. In some cases, it's totally acceptable, but in others, maybe not. So unfortunately, we don't know ahead of time what loggers will be available to put more specific descriptor. To address that issue, we could use a Dependency Resolver class. That allows us to define and retrieve dependencies that can be reconfigured at the deployment time. To do that, we shall add a Dependency Resolver to our component. In the constructor, we define a dependency to logger and set a default descriptor. In the configure method, we should pass configurations to the Dependency Resolver so it can reconfigure the dependencies. And finally, in setReferences method, we pass references to Dependency Resolver, and then we retrieve our logger dependency by its name. And at the deployment time, we can reconfigure those dependencies by adding a dependency section to the component configuration. For instance, in the example, you can see that we have two loggers. Without Dependency Resolver, or just by using default configuration, our component will get references to the first logger. But if we need to pass reference to the second logger, we can redefine logger dependency and point to the specific logger using its unique name in the descriptor. If you're interested to learn more about Pip.Services, visit our website at www.pip.services.org and subscribe to our channel. Thank you.